Electrical engineering is one of the best engineering majors or career paths that you can choose in 2021 and beyond. Next year, it will pass civil engineering and take the cake for more employed engineers in the United States than any other category. The most recent data shows that the median salary is just over $100,000 a year, which is not something that civil or mechanical engineering can say, nor can industrial engineering, the next three most common types of engineering. And because of its attachment to computer programming, electrical engineers can get almost any type of software engineering or coding job they can imagine. It ranked number 1 on my engineering degrees tier list video that came out a couple weeks ago, and it's doing super well and it's very deserved. But now we're gonna go over some of the best types of electrical engineering jobs based on something they call areas of technical competence. Each and every one of these types of job avenues makes far more than the median salary of electrical engineers in general, and some of them boast median salaries like $215,000 and $185,000. I just can't believe how much money you can make as an electrical engineer. So in this video, we're going over the top 10 jobs, my electrical engineering tier list, and we're starting right now. Hey 1% Nation, I'm Jake Voorhees and welcome back to the 1% Engineer Show, where we empower young engineers to rise to the top 1% of their career. So if this is you, make sure you hit the notification bell and subscribe. This is episode 139 of the show, so if you're new here, make sure you check out our other videos. See the description below for access to the 1% Engineer Kit, where you can sign up for our newsletter, access to our Discord server with 1,400 engineers, and our Instagram page. This video is backed by data from the 2019 IEEE USA report that has looked at electrical engineering salaries for the last 33 years, and I am blown away by how high some of these salaries are for these job categories. You're going to be pleasantly surprised with some of these and overall shocked by others. You're going to see some jobs ranked as the illustrious S tier, some pretty good as A tier, and some that are okay as B tier. They're sprinkled all around and not necessarily in a particular order, so make sure you watch this video till the end. What type of electrical engineer do you want to be? I respond to 100% of comments nowadays, so leave a comment below with any type of question or any sort of concern about engineering. I will answer it. Without further ado, guys, let's get right into this video with category number 1. Yep, we're starting off with the highest type of salary. I'm going to give it to you guys right up front and center, which is smartphone and watches engineers. This is the job category where the median salary, including benefits and bonuses, is $215,000. I have never in my entire life seen a salary like this that is outside of the C-suite, outside of the executive corporate ecosystem. Electrical engineers are some of the heroes within the ongoing revolution in mobile devices like smartphones and watches. While much attention has been focused on the user-facing design of smartphones and other contemporary electronics, the internal functioning of these devices is just as important to their ultimate acceptance by organizations and individuals. For instance, their CPUs, networking capabilities, and batteries dictate their look and feel. And all of these components are the work of electrical engineers. Let's take a look at all of the most recent iPhone designs, the 12, 11, and the X. One of the biggest storylines about these handsets is the distinctive notch, black bar intruding into an otherwise edge-to-edge organic light-emitted diode or an OLED screen. Opinions differed on the elegance of its appearance, but its placement was ultimately determined by engineering constraints. Apple's electrical engineers had to fit many advanced electronics into that notch, including a dot projector, flood illuminator, proximity sensor, and infrared camera. These features work in tandem with the phone's front-facing camera to support the Face ID authentication system, which is an alternative to signing in with the passcode. Due to the total size of all of the different hardware required for accurately scanning someone's face, the notch reached down into the top center of the OLED display. High-profile mobile tech like the iPhone is hardly the only domain for electrical engineers working in this category, but it is the highest paying and the fastest growing. In each of these fields, electrical engineers operate largely out of the public eye to ensure the efficiency, safety, and cost effectiveness of the numerous essential systems underpinning today's hottest technologies. Their work doesn't normally catch the public's attention like the iPhone models, but it always makes a difference in how numerous in-demand gadgets and infrastructures actually function. Without question, electrical engineers working on smartphones and smartwatches is an S-tier avenue, guys. If you are interested in electronics at all, this is exactly one of the directions things that you should consider for your career. The next job category is energy and power engineering. I got a lot of questions about energy engineering and some about power in the mechanical engineering job tier list video that came out last week. Many engineers consider mechanical versus electrical engineering. I made a video specifically with that title, and if you're interested in seeing the job tier list for mechanical, go check out that video after you watch this one. Let's first define the differences between energy and power. Energy refers to a variety of resources that can be obtained directly or through processing or conversion. This includes primary energy, which is an energy form found in nature that has not been subjected to any human-engineered conversion process. This includes oil, coal, peat, and shale, natural gas, biofuels and waste, nuclear, hydro, and renewable energy. Hydro was already mentioned, but other renewables include wind, solar, biofuels, and geothermal energy. Energy engineering is the broader subject of the generation and use of power. It includes energy sources like combustion, nuclear, solar, wind, tides, and how they are used to generate useful work, which can include electrical, but this is only a part of the industry. This also includes environmental matters, thermodynamics, power conversion systems such as motors, turbines, or refrigeration. It will include some study of electrical power distribution systems, but basic circuitry and other similar uses are excluded. Power engineering was one of the oldest and earliest fields that developed within electrical engineering. It deals with generation, transmission, and distribution of electric power, which requires the aforementioned energy aspects. Power engineers also work on a variety of power devices and on power conversion, the process of transforming power from one form into another, such as with electromechanical or electrochemical processes. Many power engineers are part of a large team that builds, maintains, and develops the large networks that connect power generators with users of its power. This is what they call the power grid. These engineers who work for power utility companies of governments that maintain power grids design components for the grid, architectures for the grid, and devices that either supply power to the grid or draw power from it. Devices that power engineers design and work with include generators, transformers, circuit breakers, and relays and transmission lines. Systems that power engineers work on include electrical substations, which is a subsidiary station of electricity generation, transmission, and distribution systems where voltage is transformed from high to low or the reverse using transformers. The median salary for energy and power engineers is $130,000, which, let me remind you, sounds much lower than $215,000, but it is 29% higher than the median for overall electrical engineers. It is tied for the 8th highest salary on this top 10 list, so the salary compared to some other things you're going to learn here is not that incredible, but power engineering is a large aspect of overall electrical engineering, particularly if you do not go into electronics, so there are a lot of jobs and a lot of potential in that industry. It's also one of the few areas where electrical engineers may get a professional engineering certification, and for these reasons, this is an A-tier job option. Okay, third on the list is robotics and automation engineering. I get so many questions about mechatronics and robotics, probably more than any other type of engineering on this channel, and there's some things here that you are going to be surprised by, but either way, it's coming in at the third mentioned job category on this list. Robotics is a multidisciplinary field which brings together a number of distinct branches of engineering, including mechanical, electronic, computer, and systems engineering, to support a vast number of industries, including mining, manufacturing, automotive, industrial services, and more. This field of engineering is centered on building machines that replicate human actions. While the manufacturing industry is an important one, robotics can also be leveraged in industries as diverse as aerospace, transportation, automotive, medicine, and everything in between. As a result, robotics engineers can be responsible for performing a wide range of duties related to those discrete branches of engineering, all depending on the organization they work for and the industry that it operates within. Robotics engineers have a broad range of responsibilities. That's why most robotics engineers need to be able to step in and respond to any of the needs of a company that may hire them, whether it be designing, installing, programming, teaching, or maintaining robots and automation systems. There's a list of duties that robotics engineers may be capable of, including conducting research to determine the parameters of a robotic application, designing robotic systems from start to finish, developing and implementing software that will control the robots, creating prototypes and working on necessary components like microprocessors, developing cost-effective and efficient processes to produce the machines. They may perform integration tests and quality control, apply machine learning techniques, creating complete documentation for the systems, monitor the use of the systems, troubleshoot defects, and updating systems as advancements are created. I was shocked to see that robotics and automation engineers are also tied for 8th on this list in salary with a median of just just $130,000, which again sounds good, but it is almost at the bottom of this list. I didn't have the heart to give it A tier because it's one of the coolest types of electronics engineering, and so many people want to go into that avenue. I think it is the future. I think it's going to increase over time. I think there is not a consumer-facing type of robotics industry yet. You can't go out and just buy a robot that just kind of works by itself, besides of Roomba and a couple other similar things. That's why things like the smartphone industry make so much money, because there's so many people buying smartphones. So I had a hard time putting this in A tier, so I gave it a combination of A/S tier for robotics and automation engineering. The fourth job category on this list is non-internet software developers. You guys might be confused, like, what do you mean non-internet software developers? But listen up. Since there is so much programming in electrical engineering, many EE graduates move into some sort of software development career or role after graduation. Software developers are the creative brainstorming masterminds behind computer programs of all sorts. While some software developers may focus on a specific program or app, others create giant networks or underlying systems that help trigger and power other programs. This is why there are two main classifications of developers: applications software developers and systems software developers. System software developers are professionals who are focused on operating system level software, compilers, and network distribution software. This role is geared more towards designing solutions for enterprise organizations. This includes developing software for sectors such as finance, military and defense, aerospace, communications, business, scientific, industrial, medical, and general computing applications. Here are some companies that hire the most non-internet system software developers, and you will notice that a few of these actually include internet or mobile applications like Amazon and these banks, but there are far more software developers working on their non-web-based systems. It's funny to look at this graph because Amazon is a tech company, IBM is a tech company, and then you have bank, defense company, general consulting, defense company, and a bank. Very few of these companies are actually technology companies because they are behemoths in their industry and they need so many people to write software for their internal applications that are never consumer facing and that are never actually on the internet, like applications software engineering, which is also on this list, but we're not talking about that right now for this job category. Another super cool job example I have for you is my friend who works as a civilian computer electrical engineer for the military. He works with the black boxes in tanks and military vehicles and things like the tracking systems between the laser guided target and the gun turret and the accuracy of whether it can keep up with the target or not. Some of these types of jobs are super cool and some of these are not as cool. The median salary for this type of job is $151,000 a year, so about 50% higher than the median of all electrical engineers. Pretty good, but I know people who are software developers at IBM and some of these banks, and they do not enjoy their job as much because it's big corporate and bottom line focused, and they may not even be able to talk about what they work on with their friends and family. So with the fifth largest salary on this list, I have trouble putting it all the way in B tier, but it's not sexy enough to put in A tier, so it's actually going to get A/B tier for non-internet based software developer jobs for electrical engineers. Okay, job category number 5. This is one of my favorite for sure, which is a machine learning engineer. In 2019, the career platform called Indeed conducted a study, and they identified that machine learning engineer was the fastest growing job title for all jobs in the world. That's right. And they said it was likely to last into the future. Machine learning is a branch of artificial intelligence where a class of data-driven algorithms enables software applications to become highly accurate in predicting outcomes without any need for explicit programming. The basic premise here is to develop algorithms that can receive input data and leverage statistical models to predict an outcome while updating outputs as new data becomes available. The processes involved have a lot in common with predictive modeling and data mining. This is because both approaches demand one to search through the data to identify patterns and adjust the program accordingly. Machine learning engineers sit at the intersection of software engineering and data science. They leverage big data tools and programming frameworks to ensure that the raw data gathered from data pipelines are redefined as data science models that are ready to scale as needed. Machine learning engineers feed data into models defined by data scientists. They're also responsible for taking theoretical data science models and helping scale them out to production level models that can handle terabytes of real-time data. Machine learning engineers also build programs that control computers and robots. The algorithms developed by machine learning engineers enable a machine to identify patterns in its own programming data and teach itself to understand commands and even think for itself. Most of us have experienced machine learning in our day-to-day lives in one form or another. Want some examples? Sure you do. Things like the recommendation engines on Netflix, right here on YouTube, and even shopping on platforms like Amazon. Self-driving cars, virtual assistants like Siri and Alexa, computing predictions like your GPS navigation, gamified learning like on Duolingo, online fraud detection, connected smart homes like the Nest application, predictive healthcare like Kensai that alerts you before you're getting sick and the symptoms arise, and even things like determining your credit worthiness. This is a super awesome job category, and if you're interested at all in data science or artificial intelligence, this is the number 2 salary on this list, and it is the one that is $185,000 a year, which is 84% higher than the median salary for all electrical engineers. This is certainly an S tier job category and most likely my favorite career trajectory for electrical engineers in general. Machine learning is one of the ways to go, guys. Okay, halfway through. Number 6 next up on this list is circuits and devices engineering. The world will be full of electronic devices for a long time, and circuit design engineers will help create and test out the unique types of circuits that allow them to function. Electronics courses will teach you to work in circuitry and control systems, among other electronics components. A circuit design engineer develops circuitry found in devices such as a computer, smartphone, or television. As a circuit design engineer, your job duties include designing the latest advances in circuits, developing circuit equipment, and troubleshooting after installation. You may also supervise the manufacturing process in plants and factories, as well as perform safety and cost assessments. Circuit design engineers are given certain specifications regarding a product or project. These specifications are used as a guideline for designing circuits and circuit boards. Designers are sometimes given conceptual designs that they can turn into real-life working circuits. Other responsibilities may include designing different types of circuits and boards, such as amplifiers and multi-chip modules. Additionally, circuit designers create signal processing filters, which extract information from electrical currents and voltages. Circuit designers must work to meet deadlines, achieve quality goals, and stay within budgets. During the design process, circuit designers perform laboratory tests using equipment such as a network analyzer, spectrum analyzer, or a power meter. They often simulate circuits using Spectre RF and Sonnet. They provide direction to layout technicians regarding circuit implementation through electronic design automation software. Circuit designers are responsible for the entire design process from conception to the finished unit. This is most likely the purest type of electronics engineering on this list. You could end up in mechatronics, you could end up working with computer systems, you can end up working anywhere that circuits exist, which is all electronics. Circuits and devices engineers come in at 4th on this list with a median salary of just under $158,000. Because it's pretty close to the middle on the salary list and it's broad, flexible, and you can go anywhere in your career, this is an A tier type of job option for electrical engineers. Circuits and devices engineering. Okay, next on this list, something you may not have ever heard of unless you have really studied electrical engineering. It is electromagnetics and radiation. Instead of saying electromagnetics over and over again, I might just say EM. EM is the study of underlying laws that govern the manipulation of electricity and magnetism and how we use these laws to our advantage. Hence, electromagnetics is the source of fundamental principles behind many branches of electrical engineering and indirectly impacts many other branches. For example, laws in circuit theory can be derived from laws of EM. The increased clock rates of computers make the electrical signals in computer circuits and chips more electromagnetic in nature, meaning that mastering their manipulation requires a fundamental understanding of EM. EM includes the study of antennas, wireless communication systems, and radar technologies. In turn, these technologies are supported by microwave engineering, which is an important branch of electromagnetics. The use of laws of EM can also extend into the realms of remote sensing, subsurface sensing, optics, power systems, and many other branches of electrical engineering. Electromagnetic engineers design and develop electromagnetic systems, devices, and components, such as electromagnets in loudspeakers, electromagnetic locks, conducting magnets in MRIs, and magnets in electric motors. Electromagnetics also produces radiation, which is why this category is called EM and radiation. There are 2 types of radiation, and this one you may never have heard of before. The first type of radiation is known as particulate radiation, which consists of actual subatomic particles being emitted from the nucleus of an atom. The second type is called electromagnetic radiation. This type of radiation, in simple terms, is energy in waveform that possesses both electrical and magnetic characteristics. If you look through electromagnetic radiation jobs, they are almost all in the aerospace sector, Northrop Grumman, Boeing, and other service providers of the astronautics and aeronautics industries. The median salary is $141,000, and because it's just so niche and there are not as many jobs, I have to put this in B tier. Okay, coming in at 8th on this list is communications technology engineering. There's a whole bunch of avenues for communications and technology, but for the sake of this, we're going to talk about telecommunication engineering here. The telecommunications industry is the backbone of today's mobile landscape, deploying voice, data, graphics, and video at ever-increasing speeds in a growing number of ways. Wireline telephone communications was once the primary service of the industry, but wireless communication and satellite distribution are becoming increasingly dominant. Specialists in telecommunications engineering are needed to keep up with this ever-changing, fast-paced industry. Telecommunications engineering is a discipline founded around the exchange of information across channels via wired or wireless means. It brings together all of the elements of electrical engineering, including computer engineering and system engineering, to create and improve telecommunications systems. Telecom engineers work to develop, design, and maintain voice and data communication systems, which include fiber, satellite, wired, and unwired, as well as the encoding, encryption, and compression of data. Put simply, telecommunication engineering can be found in just about every aspect of our lives, from GPS navigation to the internet. Some of the main areas of focus for telecommunications engineers are the installation of high-speed broadband computer networks and optical and wireless or satellite communications. To give a better idea of the scope of work a telecom engineer operates within, here are some career opportunities for individuals working within this discipline: computer communications and networking, mobile communications, voice and data networks, TV and radio broadcasting, optical networking, remote sensing, measurement and control, and next generation networks. Communication technology engineers are third on this list for salary at $161,000 a year. It is an industry that is never going to go away. It's going to continue to change and evolve with a high salary, a fun industry, a lot of jobs, and a great future outlook. This is another S-tier job option for electrical engineers. Okay, 9th on the list is internet web developer and applications engineers. For simplicity, we're going to call this application software development or just application development. We have already heard about system software development, guys, which is the other half of software engineering or software development. Those types of engineers work in enterprises where their work is internal to that company and regular internet users or consumers will never see the programming. Computer application software engineers help to design, program, test, maintain, and repair computer applications for businesses, private consumers, and internet users. Most computer application software engineers have a bachelor's degree in computer science or electrical or computer engineering who lean into the computer science side of the major. Application software engineers design and develop software applications such as utility programs and general application software. They work with the user to determine needs and create software to meet users' needs. They modify existing software to fix problems, optimize functioning, and enable its use on new hardware platforms. They oversee installation of software systems as well as monitor equipment. These engineers also perform testing and validation of software systems to ensure that applications work properly. While some computer application engineers design and produce commercially sold software suites, most design or customize applications for businesses or other organizations. Some application engineers design and analyze databases within a given application area. Applications engineers must communicate with systems analysts, engineers, and programmers to get information on project limitations, performance requirements, and interfaces. They consult with clients in the design phase to determine clients' needs. After an application has been released, they help consumers with maintenance issues. Companies that you might work for as this type of engineer include Google, Facebook, Apple, Microsoft, Oracle, SAP, Salesforce, Adobe, PayPal. You get the idea. These are software applications engineers, and typically when you're thinking about software engineering, this is the one that you are considering. These types of engineers is essentially tied for 6 on this list for salary, again at $141,000 a year, because there are so many people in Silicon Valley and in all the tech sectors all over America and all over the world working in this avenue. There are tons and tons of jobs, tons of cool areas. The salary is pretty good, 40% higher than the median salary for electrical engineers, and for that reason, this is certainly an A-tier job option for electrical engineers. Okay, last but not least, guys, is instrumentation and measurement engineers. Instrumentation engineering focuses on control processes that use sensors as an input. This field of engineering can be concerned with the equipment processes using sensors to observe many types of variables, including pressure, pH, voltage, temperature, and many more. Feedback from such sensors can be used throughout the manufacturing process. They can measure and monitor things such as specific machine outputs, the efficiency of systems, and most importantly, safety parameters. They can also play an incredibly important role in the monitoring and recording of quality data to ensure the safety and reliability of the final product. In addition to simply monitoring, the feedback given from these systems and processes can be fed back into the system to alter and control the manufacturing process, optimizing efficiency and safety. The ultimate aim of instrumentation engineering is to ensure that control machinery and processes are working to achieve maximum productivity in an optimally efficient, safe, and reliable manner. Instrumentation engineers are responsible for planning, installing, monitoring, and maintaining control systems and machinery within manufacturing environments. They typically work with control processes that use sensors to provide feedback. As a result, that can also have a role in designing and developing customer products that utilize such processes, such as blood glucose meters or smoke detectors. This engineering career avenue, even though it is 24% above median salary, is actually last on this list at $125,000 salary. After I read a bunch of job descriptions, it doesn't seem like it is that thrilling of an avenue. Yes, if you're in love with it, you can have a great career, but because the salary isn't as high on this list, and you already heard about how interesting it is, this is a B tier job option. So there you guys have it, the entire list of the top 10 job avenues for electrical engineers. What are you guys most surprised by? That robotics was 9th on this list, or that smartphone engineers make a median salary of $215,000? Comment below. Again, I respond to 100% of comments nowadays. So if you have a question or engineering concern, make sure you leave it in the comments below and I will help you out with that. We have a Discord server with 1,400 engineers and we're looking for a social chair and someone to be on that team to help us run it. So if you're interested in being a part of the Discord team, let me know in the comments below. We also have a couple openings on the overall 1% engineer team. There's about 10 young engineers from all around the world who help me out on different aspects of this channel and project and community. So if you want to join the team as an official intern for 1% engineer, comment below. Thanks again for watching the 1% engineer show, guys, where we empower young engineers to rise to the top 1% of their career. So if this is you, make sure you hit the notification bell and subscribe. We have 138 other episodes on the channel, so check those out. And in the links below, you can sign up for our newsletter through the 1% Engineer Kit and go follow us on Instagram so we can cross the 500 follower mark. Thanks again for watching the 1% Engineer Show, guys, and we'll see you again in another video. Bye-bye.